Hello, and welcome to Solving Rational Equations. This is going to be an intermediate algebra look, which means most of our examples will be easier than what they could be later on in college algebra, pre-calculus, and that sort of thing. So in order to solve rational equations, first we're going to state what values should be excluded by finding the domain of each expression. This is very important. This is the reason we're able to do step 2. Step 2 is we're going to multiply both sides of the equation, everything on both sides of the equation, by the least common denominator. We'll solve the remaining equation and then check the answers in the original. Alright, so for this first problem, 35 over x plus 3 equals 5. We know that x plus 3 cannot be 0, so x cannot be negative 3. So we'll just kind of set that on the side. Now, we're going to take our equation, 35 over x plus 3 equals 5, and we're going to multiply both sides of this by that denominator. There's only one denominator here, so it is the common denominator. When I multiply both sides of my equation by the denominator x plus 3, on the left it cancels, and on the right we can distribute. We'll now have 35 equals 5x plus 15, and we can solve. Subtract 15, we'll get 20 equals 5x, which of course we will divide both sides by 5 to get x equals 4. We found our answer, x equals 4. It's not negative 3, so that's pretty cool. And we could check it. Well, why did I write a 25? That should be a 35 over 4 plus 3. That is 35 divided by 7, which is 5. Fantastic. So we know we have the correct answer. Let's try it again. All right, first step. First step, we know that, let's take this in blue. X plus 3 cannot be 0, so x cannot equal negative 3. So we will not circle an answer that is negative 3 because we know in the original it doesn't work out. Okay, let's write our equation here. Let's put that 7 over here. X plus 3, there we go, yep. Sorry, it's a recording, I shouldn't go silent. 8 over x plus 3 equals 7 minus 6 over x plus 3. So we're going to multiply everything by x plus 3. We'll multiply the 7 by x plus 3. We'll multiply the 6 over x plus 3 by x plus 3. We'll multiply the 8 over x plus 3. Everything gets multiplied by the x plus 3. And we can do that because we've already taken care of that denominator. We're saying here in blue that it can't be 0, because if it were 0, we'd just be making the whole equation equal to 0. So assume it's not 0, so the answer can't be negative 3. Now we can multiply by this, because now we're not multiplying by 0. And what happens next? Well, the x plus 3's cancel out. X plus 3's cancel out. We'll distribute where we need to, so we have 8 equals 7x plus 21 minus 6. And this is an equation that we can all solve. 8 equals 7x plus 15, right? 21 minus 6 is 15. Let's subtract 15 from both sides. If negative 7 equals 7x, we'll divide both sides by 7. X equals negative 1. Negative 1 is not negative 3, so it probably works out. But we can check the left-hand side. 8 over negative 1 plus 3 is 8 over 2, which is 4. The right-hand side of my equation is 7 minus 6 over negative 1 plus 3. That's 7 minus 6 over 2. That is, let's put the equal sign down here, 7 minus 3, which is 4. Fantastic. Both sides are equal to 4, and so we know that our answer is correct. And that's all it takes. Okay, so make sure that we're not multiplying everything by 0, because when you multiply an equation by 0, it's kind of like cheating. It's mathematical cheating. Everything's good when you multiply by 0. Okay, so what can the denominator not be? Let's write that over here. X minus 7 can't be 0, so x cannot be 7. And x minus 6 cannot be 0, so x cannot be 6. And while we're at it, the least common denominator is x minus 7 times x minus 6. And the first two examples, our fractions all only had a single denominator, but now we have two different denominators. So as we multiply, 4 over x minus 7 equals 8 over x minus 6. Let's multiply both sides by that common denominator. And remember, when we're multiplying by this common denominator, if you need to, write that denominator of 1, that unwritten denominator. You could write it, it's all right. As we cancel, on the left, the x minus 7 will cancel with the denominator x minus 7. And on the right, the x minus 6 will cancel with the x minus 6. So we have 4 times x minus 6 equals 8 times x minus 7. Now, a quick note on this. As you look at the problem number 3 as it's typed, and then you look at what I just wrote in black at the very end, you'll see where we say sometimes cross multiply and set equal to each other. This is called a proportion. Anytime you have one rational expression equal to another rational expression, it's a proportion. So this process that we're doing of multiplying both sides by the LCD reduces to be cross multiply and set them equal to each other. So that's where that comes from. 4x minus 24 equals 8x minus 56. I'm definitely going to take this up over here in order to do any work. No work whatsoever, just rewriting it. Let's take our x's to the right, just because I like to be a positive person. Let's take our numbers to the left. Okay, I was going to do that in my head, and then I noticed I shouldn't. 56 minus 24. Oh, 32. Yeah, I could have done that in my head. 32 equals 4x. Divide them both by 4. Should be x equals 8, right? 32 divided by 4. 8 looks good. 8 is not 7. 8 is not 6. So we're pretty confident. Let's see. Let's check it. Our left-hand side. 4 over 8 minus 7 is 4 over 1, which is 4. Whereas 8 over 8 minus 6 is 8 over 2, which is also 4. Fantastic. We know that x equals 8 is the correct answer. 4 steps. First step, what can the answer not be? Second step, multiply both sides by the common denominator. Multiply everything in the entire equation by the common denominator. Simplify to solve, and then we check our answer. All right, we got this. We got this. Now, of course, it's going to get a little more challenging. So in order to find our least common denominator, in order to find really anything to start with, we should factor our third, our denominator on the right-hand side. And here's a tip. As soon as I said it was intermediate algebra, it means that it's going to factor like this. And we can check that and make sure. Two things that multiply to be a negative 6, so they're going to have opposite signs. Multiply to be 6, they're different by 1, so we know it's 3 and 2. The 1 is a negative, so the bigger number, the 3, has to be negative. And we see that, oh, this is our LCD. So our least common denominator is a minus 3 times a plus 2. We know that a minus 3 cannot be 0, so a cannot be 3. We know that a plus 2 cannot be 0, so a cannot be negative 2. So we'll keep those in mind. as we work on this problem. Now, let's see if I can do this without being lazy. I'm going to have, I don't think I can. Okay, here we go. 3 over a plus 2 plus 5a over a minus 3 equals 75 over, and I'm going to write it in factored form just because it's easier to look at as I write what we're multiplying by. A minus 3, a plus 2, cram it in there. A minus 3, a plus 2, a minus 3, and a plus 2. Right? We want to multiply every single term, both sides, but remember it gets distributed every single term. So here my a plus 2's cancel. In the 5a over a minus 3 times a minus 3 times a plus 2, my a minus 3's cancel. On the right hand side, both of them cancel. And that's what's so nice about multiplying by the LCD. It's going to take out all these denominators. That's what we want. 3 times a minus 3 plus 5a times a plus 2 equals 75. Now we'll distribute. 3a minus 9 plus 5a squared plus 10a equals 75. As soon as I said a squared, I had going off in my head. So we have a quadratic. We have to solve this. Anytime we're solving a quadratic, we'll get everything on one side of the equal sign and set it equal to 0. So we have a 5a squared. The 3a and the 10a make 13a minus 9. My a's are turning into c's. Equals 75. And if I have a negative 9 and I subtract 75 to the other side, that'll be a negative 84. So I'm looking at 5a squared plus 13a minus 84 equals 0. Next step, we factor. Oh, we factor. Okay, so let me give us some more room here. Let me see if I can find my cursor. I cannot find my cursor. Let's find the cursor. Here we go. Now we're at least on the right page. There we go. Let's give us some more room here. Okay. So we're going to multiply 5 times negative 84 420. It's a negative 420. And it adds to be 13. Well, we know that 5 and 84 are pretty far apart. And the 13 is positive, so the bigger numbers will be positive. So let's go something a little closer together. Let's see what happens if we divide by 20. Well, that's 20 and 21, right? 420 divided by 20 is 21. Well, they're too close. They're only off by 1. So we need something a little wider apart. So we know that our smaller number has to be between 5 and 20. Instead of doing the just chug it out 1, 2, 3, and so on, I'm doing guesses. They end up taking about the same amount of time as if you were to just chug it out. But I am a good guesser. It comes from being a math professor and having a familiarity with numbers. But you could get there eventually, right? You would eventually check, does 15 go into 420? So this is called the AC method in my world. We're going to use the negative 15 and the 28 to rewrite the 13. So we have a negative 15a plus 28a minus 84 equals 0. These first two have a 5a in common. When I factor that out, I'm left with an a minus 3. We'll use the sign in the middle. 28 and 84. Now I'm really hoping that 84 is divisible by 28, and I'm hoping that gives us a 3. Why a 3? Because if I factor out a 28, remember in parentheses, I really want them to be the same. So now I have a minus 3 in common, and I'm left with 5a plus 28 equals 0. Let's see, why not? Just take it a couple more lines here. Two things set equal to 0, then neither of them can be 0. Excuse me, let me rephrase that. If two things multiply to give us 0, then one of them must be 0. On the left, we get a equals 3. On the right, 5a equals 28. So a equals 28 fifths. But we know from the very beginning, we cannot have a equals 3. So we would not include that answer. A equals 3 is what we call extraneous. Now, extra is the really important part of it. Extraneous. It's an extra answer that comes about from the process we used, but we know from the original problem that that's not a viable answer. So we have to toss it, and our only answer is 28/5. And as always, I encourage you to check your answers, but I'm not going to because we're running a little low on time right now. I don't want this video to get too long. And I'm kind of lazy. Okay. Now these are such good problems. And these are the ones that give people a hard time because this is why we need math. This is a real world problem that might happen. I don't know why you're filling your garden hose, filling your backyard pool with a garden hose, but maybe that's the only option you have. Let's figure out how much time is it going to take? It takes a garden hose 48 hours to fill a backyard pool. So I'm going to write this down over here. Hose 48 hours to fill. A fire hydrant, that's getting pretty dramatic, can fill the same pool in 20 hours. How long will it take? So find the time to fill the pool if both the garden and the fire hydrant are used. All right, so they're working together. And this is really a rate type of question. If it takes, where do I want to write this? If it takes the garden hose 48 hours to fill, it could do 1/48 of the job in 1 hour, right? 48 hours to fill, 1/48 of the job every hour. The hydrant can do 1/20 of the job in 1 hour, right? It takes 20 hours to fill, so 1/20 of the pool is filled every hour. After 20 hours, it's finished. So we're going to work together. So working together, 1/48 of the job added to 1/20 of the job will give us a rate of 1/t, where t is time filling together. So we can use this rate of work in order to first write a rational equation, and now we know exactly how to solve it. And I am going to figure out the LCD here. We have 20 and we have 48. 20 is 4 times 5. 48 is 4 times 12. Now I know what you're thinking. Those are not completely simplified. But I found a common factor here. And so my LCD has to have the 4. They both have that. It has to have a 5 and has to have a 12. So it looks like it is 240. Now you could always just multiply 48 times 20 and get a common denominator. But it's much easier to use the least common denominator as we're doing these problems. So let's multiply everything by 240. T because there's a t in the denominator here, so we can't forget about it. 240 t. So when we simplify, 240 divided by 48. I bet some of you already know that answer. Yep, it's that 5 t plus 240 divided by 20. That's the 12 t. T's cancel out. We get 240. 5 and 12 is 17t. 17t equals 240. T will be 240 over 17, but I got to tell you, an answer like a equals 28 over 5 for just some random equation, that makes sense. But if you tell your friend, hey, you want to come over in 240 divided by 17 minutes to go swimming, they'll probably say no. Like, unless, well, you have friends like mine that just laugh at you and then, yeah, I'll be over there, just let me know. 14.11764706, so we'll say 14.1 hours if they work together. That hose doesn't go very quickly. And so the hose doesn't help a lot with the hydrant, but it helps enough to make it, a single waking period of time instead of overnight. All right. Jim, working alone, can paint a house in 30 hours. So I'm going to put Jim, 30 hours for one job. Mary, working alone, can paint a house in 24 hours. Jim needs practice. How long will it take if they work together? Working together, we'll add them together. So we'll have the 1/30th of the job that Jim can do in an hour, plus the 1/24th of the job Mary can do in an hour, and that will equal the rate that they work together, 1 over t. So we'll have t, we'll have 24, and we'll have 30. 24 and 30 both have a 6 in common. So my least common denominator will have that 6, the 4, the 5, and the t. 20 times 6, 120t is our least common denominator. So we'll multiply 120t by each piece of our equation. 120t divided by 30 is 4t. 120t divided by 24, that will be 5t. You can check it with the calculator, make sure I'm not lying to you. Equals 120. Now notice the numbers that they didn't have in common, right? The 30 was missing the 4. Oh, looks like that's what we got. The 24 was missing the 5 from the common. Oh, that's what we got in the numerator. And the t was missing both the 120. All right, so it works out to what we talked about earlier in this chapter. If 9t equals 120, t will be 120 divided by 9. Let's at least simplify that. 120 divided by 9. Yeah. That's a repeating 3, so it doesn't tell us how to round. I'm going to say 13 hours and 20 minutes because 1/3 of an hour is 20 minutes. 13.3 is a good answer too. I like these to be in actual times. Like, I'm not gonna pay Jim to paint my house for 30 hours. I'm not gonna give up 3-4 days. I don't know how long that would take because it wouldn't be 24 hours. I need to sleep. I need them out of my house. I'd much rather pay the two of them together 13 hours to paint my house. All right, so working together, we add them. What if they were working opposite of each other? Now you got to figure out, how does that subtraction figure out? How do they work against each other? That's more for a college algebra take on this. But that's it for now on solving rational equations. Thank you very much for listening.